Distributive property, that's going to be our topic for today. Our learning target is students will be able to use the distributive property to write equivalent expressions. So this is another method of solving some problems, and as we get into algebra and using variables, sometimes you have to use the distributive property in order to answer or simplify the problem. If it's all numbers, it's just another method. Okay, go ahead and write that down. I'll be moving on to the next slide. Okay, what is a distributive property? The distributive property is evaluating the product of a number and a sum or difference. So that's what the distributive property is. So I have some 4 examples of what the distributive property could look like. So product, remember, means to multiply. So in each one of these examples, I have multiplication. So 4 times that right there, 5 times that part right there, a times that part there, and a times that part there. So there's my product. And then it says the product of a sum or difference. And if you notice in each set of parentheses, I have either sum, which is adding, or difference, which is subtracting. So I'm finding the product of something in parentheses that you're adding or subtracting. Okay. Now what happens is you distribute that number you're multiplying to each number inside of the parentheses in the sum or in the difference. So if we look at this first example right here, I'm doing 4 times 6, and then I'm also doing 4 times 3. So I'm not just doing 4 times 6, and then stopping and then doing plus 3, I have to do 4 times the 6 plus 4 times the 3. And that's where the distributive property comes from, because you're distributing the 4 to each number. If you look at the second example here, it's 5 times the 7, 7 times 5, and then the 2 times the 5, 2 times 5. So that you can see that in the second half is what I get after I distribute it. Okay? There was subtraction in that problem, so I have subtraction in my other part. With letters, just general speaking, okay, that's what I have over on the other side. So A times B plus A times C. So, sorry, this should be B times A right here. B times A. Okay, so I'm multiplying A to each part in there. Okay, so that's how you do those with the distributive property. Let's put it to use, and it starts to make more sense when you can see it in some application. If you need to pause, go ahead. Otherwise, I'll be moving on. Okay, writing equivalent expressions. So most of you would solve this problem. Okay, you'd use order of operations, and you would add those together and get 150, and then you would do 2 times 150 and you get 300. And that is fine. Okay, if I were to use the distributive property for these, what I would do for the distributive property is I would distribute 2 to each of the numbers. Now you need to know this because sometimes they ask for equivalent expressions, and sometimes you don't want to go all the way down to 300. Maybe you want to rewrite it in a different form. So this would be in a way. So this I would do 2 times the 90 plus, and then I would do 2 times the 60. So I have to multiply 2, the number that's being multiplied, to each part on the inside. Now that's an equivalent expression. Now if I were to answer this one, 2 times 90 is 180. Plus 2 times 60 is 120. That's an equivalent expression, and that equals 300. So the distributive property is a different way of solving the problem. Notice I get the same answer, but what it does is it gives me a variety of equivalent expressions. So I get in the part A, I only had 2 times 150 and then 300. In the second method, I had multiple. I had now 3 different equivalent expressions. So it just gives me different ways of writing them. Okay? If you need to pause, go ahead. Otherwise, I'll be moving on. Okay, sometimes you want to write it in the distributive property, so you want to do the reverse of what we're doing. So you want to take something like this, and you want to look, and you notice that, hey, I am multiplying 4 to each one of these numbers. So instead of doing 4 times 15 is 60, plus 4 times 10 is 40, plus 4 times 5 is 20, okay, and then getting 100 plus 20, which is 120, you might say, you know what? I'm noticing I'm multiplying 4 to all of those. So I'm actually going to write it as 4 times 15 plus 10 plus 5. Now I'm going to add up all of those numbers, and I'm going to do 4 times 15 plus 10 is 25, plus 5 is 30. I'm just going to do 4 times 30, which is 120. So sometimes you want to take the distributive property and you want to write it out in its different pieces. You may also look at a problem and say, hey, I'm noticing that you're multiplying the same number each time. I'm going to write it as this. I'm just going to add up 15, 10, and 5, and then multiply that by 4. That would be faster. So there are real-life applications for using both. So that you need to understand that you can go either way with it. It's not just a one-way track. You can go the opposite direction, the inverse direction for that also. Okay? If you need to pause, go ahead. Otherwise, I'll be moving on to the next example. I'm going to break this into 5 times 43. So I'm going to do 5 times 40 plus 3, because this is 40, remember, not 4. That's 40, 4 tens, and that's 3. So I'm going to do 5 times 40 plus 3, because 40 plus 3 is 43. I just have to make sure whatever's in the parentheses equals what I have in my my original number. Okay, now I can distribute that. 5 times 40, and I would be doing this in my head, okay, but I'm going to show you what it looks like. 5 times 40 is 200, plus, and then I do 5 times 3, which is 15. 200 plus 15 is 215. So that's my thought process. I'd be saying, all right, 43 is 40 plus 3. So 5 times 40 is 200, 5 times 3 is 15, 200 plus 15 is 215. And there you go. Okay? Now for example B, I could do 5, I could break it into my whole number and then my decimal, which I'm going to do, but I'm not going to use 5 and 95, because 3 times 95 is a tough problem. So what I'm going to do is I'm going to use subtraction. I'm going to actually think of this as 6 minus 0.05, 5 hundredths. So I'm going to multiply 3 to those. So in my mind I say, okay, 3 times 6 is 18, minus 3 times 0.05. Okay, well 3 times 5 is 15, guys. And then I have 2 numbers behind the decimal point, so I just have to remember in my mind to move my decimal point over 2 spots. 1, 2. Okay, now 18 minus 0.15, that should be not too hard. Okay, think of 100. How do I go down? Well, it's going to be less than 1, so it's going to be 17, and then 100 minus 15 is 85. So that is 17.85. And that's how you could do that mentally. It's a little harder with decimals, okay, but you know, you can still do it and break it into its parts. And you can use adding or subtracting to accomplish that. All right? If you need to pause, go ahead. Otherwise, I'll be moving on to my last slide. Okay, now we're going to be doing it with variables. You're actually going to probably find these. Misspelled expressions there. That should be 2 S's. You're actually probably going to find these a little bit easier. There's a little bit less work, and it really shows the distributive property, and you have to do the distributive property. You cannot add x plus 7. We'll talk about that more later. So you have to use it here. You have to multiply 3 times x, and you get 3 times x, which is 3x. Okay, you can multiply that to get 3x. Plus, then I do 3 times 7. Plus 3 times 7 is 21. Nothing else I can do there, guys. That's all I'm going to do. 3x plus 21. That's not 24x. Okay, that is wrong. Okay, you just leave it as that. And we'll explain more of why we do things later, but that is what you get. Okay, doesn't matter if it's at the end here in B. I can do 2 times the n, so I can do n times 2, which is 2n, plus, and then I can do 2 times the 4, which is 8. And again, just leave it. Nothing else you can do. You can't add those together. You're just, when there's variables involved, it's a lot different concept of adding. So you just do that, you're done. The answer again is not 10n. That is incorrect. Okay, you just multiply those, and then you're done. Okay, 2 times n is 2n. 2 times 4 is 8. You're done. Okay, and that's all that we have for today. So